Newton's third law of motion states that for every action there is an equal and opposite reaction. When a force acts upon an object, the object will act back with equal magnitude. When two objects contact each other, this contact interaction results in a pair of forces, one of each object. This pair of forces acts simultaneously on the two interacting objects. These forces are called interaction force fields. The demonstration for this law, Newton's cradle, is a set of metal balls that are held up by strings attached to a stick. When a ball on one side of the cradle is lifted and released, it hits the nearest ball. This transfers its energy through the rest of the balls all the way to the final one.
As described previously, when the ball that is released from one side hits the next ball, the energy transfers over through all the others, which causes the ball on the opposite end to shoot up with nearly the same strength. This demonstrates Newton's third law of motion, in which every action has an equal and opposite reaction. In reality, this action-reaction process is happening to each ball on the chain, but the reaction is only visible at the last ball on the chain, since it has nowhere left to go but out and up, the opposite motion of the first ball drop. The cradle is also able to run for so long because even despite all the collisions, most of the energy is conserved throughout.